At first glance, an aircraft carrier looks like one of the strangest airports ever built. It has no concrete runway, no fixed location, and no peaceful empty space around it. Instead, it is a moving steel airfield surrounded by ocean, wind, salt, noise, fuel, weapons, jet blast, and hundreds of people working only a few feet from danger. And right on top of this floating airport stands something that seems almost illogical. A tall tower rising from the flight deck, exactly where open space appears most valuable. This structure is called the island. And the first question is simple. Why is it still there? The answer begins with what an aircraft carrier really is. It is not just a ship, and it is not just an airport. It is both at the same time. The crew must control the movement of the vessel through the sea while also managing aircraft that are taking off, landing, parking, refueling, and being moved across the deck. On land, airports have control towers because pilots, vehicles, and runway crews need constant coordination. At sea, that problem becomes far more difficult because the runway itself is moving. The carrier turns into the wind, rises and falls with the ocean, and may operate in poor visibility, rough weather, or military pressure. The island gives the crew a raised place to see and command this complex environment. From there, officers can watch the flight deck, observe aircraft movement, monitor the sea ahead, and coordinate with other parts of the ship. Modern sensors, radar, cameras, and digital systems are extremely important, but direct visibility still has value. A person looking out from above can notice motion, spacing, deck activity, smoke, weather, or a small developing problem before it becomes a larger one. On a carrier, seconds matter, and awareness is not built from one source alone. The island also serves as the ship's bridge. An aircraft carrier may look like a runway first, but it remains a massive vessel that must be steered, navigated, and kept safe. The crew needs to understand sea conditions, nearby ships, wind direction, and the movement of the entire carrier strike group. A bridge hidden deep inside the hull could rely heavily on screens, but placing it high gives better natural visibility and a practical command position. This does not mean every decision happens by eyesight alone. It means the island adds another layer of awareness to the ship's systems. There is also a technical reason the island rises above the deck. Radar arrays, antennas, communication equipment, sensors, ventilation routes, and other systems need height, separation, and clear lines of operation. A carrier must communicate with aircraft, coordinate with escort ships, track what is happening around it, and manage traffic in the air and on the deck. The island gives these systems an organized place to live without scattering them across the runway area. So the island is not simply an obstacle left over from older ship design. It is a compromise that solves several problems at once. It takes up space, but it gives back visibility, command, communication, navigation, and control. From a distance, it may look like a strange tower on a floating airport. Up close, it is closer to the carrier's nervous system, the place where the ship, the aircraft, the ocean, and human judgment come together. The idea of a completely flat aircraft carrier seems attractive at first. If the flight deck is the most valuable space on the ship, then removing the island sounds like an easy improvement. More open deck area could mean more room for aircraft, fewer obstacles, cleaner airflow, and perhaps even a more futuristic shape. On paper, it feels logical. Turn the carrier into one uninterrupted runway at sea. But aircraft carriers are not designed for clean paper diagrams. They are designed for wind, waves, aircraft emergencies, human movement, mechanical failures, and combat pressure. In that world, a perfectly flat carrier creates problems that are harder to solve than they first appear. The first issue is command visibility. A carrier deck is not simply a flat surface where aircraft take off and land. It is a crowded, constantly changing workspace. Aircraft are parked in tight groups, moved by tractors, armed, fueled, inspected, launched, recovered, and sometimes repaired while other aircraft are still operating. Crew members in different colored jerseys move around jet blast, spinning rotors, hot exhaust, weapons, cables, and elevators. From above, the island gives controllers a clear view of this dangerous choreography. Cameras can help, but they do not fully replace the depth, context, and instant judgment that come from watching the deck directly. A flat carrier would still need flight control. That control room could be moved below deck, but then the people making decisions would depend heavily on cameras, sensors, and reports. In normal conditions, that might work well enough. But carrier operations are built around layered safety. When weather worsens, when a camera angle is blocked, when smoke appears, when an aircraft stops in the wrong place, or when the deck suddenly changes status, direct observation becomes valuable. The island is not there because technology is weak. It is there because the carrier cannot afford to depend on only one kind of awareness. The second issue is navigation. An aircraft carrier is still a ship, and an enormous one. It must steer safely through open ocean, operate with escort vessels, turn into the wind for flight operations, avoid hazards, and respond to changing sea conditions. A raised bridge gives the crew a wide view of the water and the surrounding formation. Even with radar, electronic charts, and modern navigation systems, the bridge remains a practical command position. Burying all ship control deep inside the hull might protect it, but it would also remove a simple and useful layer of human perception. The third issue is equipment placement. Radar arrays, antennas, communication systems, electronic sensors, air intakes, ventilation routes, and exhaust paths need height, spacing, and clear lines of operation. If the carrier were completely flat, these systems would still need to go somewhere. Placing them flush into the deck could interfere with aircraft movement, reduce performance, complicate maintenance, or create new hazards. The island gathers many of these functions into one vertical structure, keeping the deck more usable rather than less. This is why the island survives. It takes away a small portion of flight deck space, but it gives back control, visibility, sensor height, communication, navigation, and operational order. A perfectly flat carrier may look more efficient in imagination, but the real efficiency of a warship is not measured only by empty space. It is measured by how safely and repeatedly it can perform its mission. For aircraft carriers, the island remains one of the simplest solutions to a very complicated problem. The island of an aircraft carrier is often compared to an airport control tower, but that comparison is almost too simple. A normal airport tower watches over runways that stay still, aircraft that follow fixed taxiways, and ground vehicles that move across a predictable surface. A carrier's island watches over something far more unstable. A steel runway moving through the ocean, surrounded by wind, spray, engine noise, and aircraft that have only a short window to take off or land safely. From high above the flight deck, the island gives the crew a view that cameras and radar can support, but not fully replace. On the deck below, aircraft are not just sitting in place. They are being fueled, armed, inspected, folded, unfolded, moved, launched, and recovered in a tight sequence. Crew members work close to jet exhaust, spinning rotors, heavy equipment, weapons, and arresting gear. From ground level, the scene can look like organized chaos. From the island, it becomes a pattern that can be watched, managed, and corrected before small problems turn into serious ones. One of the most important spaces inside the island is primary flight control, often called Pri-Fly. This is where aircraft operations on the flight deck are monitored and coordinated. The people there are not flying the aircraft themselves, but they help control the rhythm of the deck. They need to know which aircraft are ready, which ones are moving, which launch areas are clear, and whether the landing area is safe. On a carrier, the deck is never just empty space. Every parked aircraft, every crew movement, and every delay changes what can happen next. Carrier landings show why this raised view matters so much. A pilot approaching the ship is not aiming for a long runway. The landing area is short, angled, and moving with the vessel. The carrier must maintain the right speed and course to create proper wind over the deck, while the aircraft must approach with precision. Landing signal officers, flight deck crews, and other systems all play key roles, but the island helps connect the larger picture. It links what is happening in the air with what is happening on the deck and what the ship itself is doing. Launch operations are just as dependent on timing. Before an aircraft can leave the deck, it must be positioned correctly, checked, cleared, and released at the right moment. A launch cannot be treated as a single action. It is part of a chain. One aircraft may be preparing to depart, another may be waiting to land, another may be low on fuel, and another may need to be moved out of the way. The island helps the crew see how these pieces fit together. This is why removing the island would not simply remove an obstacle. It would remove one of the best places to understand the whole system at once. Modern carriers use advanced sensors, radios, displays, and cameras. But carrier aviation still depends on layered awareness. The island combines direct sight, communication, sensor information, and human judgment in one elevated position. So when we look at the island, we are not just seeing a tower on a warship. We are seeing the control point of a moving airport, where every aircraft, every signal, every gust of wind, and every decision must fit into a narrow margin of safety. That is why the island remains so important. It helps turn one of the most dangerous workplaces at sea into a system that can operate again and again. The island of an aircraft carrier is easy to notice because it rises above the flight deck. But some of its most important work is not dramatic at all. It is not only a place where people look out over the deck. It is also a structure that carries equipment, organizes airflow, supports communication, and gives the ship a high point for sensing the world around it. In that sense, the island is less like a simple tower and more like a vertical backbone for the carrier. Radar is one of its most important hidden jobs. A carrier is not just concerned with aircraft landing on its own deck. It must understand the airspace around it, the movement of friendly aircraft, nearby ships, weather conditions, and possible threats. Radar systems generally benefit from height and clearer lines of sight because the higher a sensor is placed, the farther it may be able to see over the curve of the Earth and above nearby obstructions. The island gives radar arrays and related sensors an elevated location without placing large equipment directly in the path of aircraft operations. Communication systems also need space, height, and separation. An aircraft carrier is constantly sending and receiving information. It talks to aircraft in the air, helicopters near the ship, escort vessels in the strike group, supply ships, command networks, and sometimes allied forces operating nearby. Antennas cannot simply be placed anywhere. They must be positioned so they can function effectively while reducing interference with one another. The island gives engineers a practical structure to mount and separate these systems, keeping the flight deck cleaner and safer. Then there is the issue of exhaust and ventilation. On conventionally powered carriers, exhaust from engines and machinery has to be routed away from working areas, and the island has often served as a natural place for uptakes and funnels. Nuclear-powered carriers do not need large propulsion smokestacks in the same way, but they still require ventilation, air intakes, and exhaust paths for many ship systems. A carrier contains machinery rooms, electronic spaces, crew spaces, kitchens, workshops, and power systems. All of these create heat, fumes, or airflow demands that must be managed carefully. This matters because the flight deck already has harsh airflow conditions. Jet engines create blast, heat, and turbulence. Helicopters and aircraft movements disturb the air even more. If ventilation and exhaust were poorly placed, they could add smoke, heat, or disturbed airflow to an already dangerous working environment. The island helps route some of these systems upward and away from the busiest areas of the deck. The island also holds command and technical spaces that need to be close to information. The navigation bridge, flight control areas, lookout positions, and equipment rooms are not randomly placed there. They are located where height, visibility, and access to communication systems are useful. Even as modern displays and sensors improve, the carrier still benefits from having people and equipment gathered in a protected, elevated center. So the island is doing more than it appears to do. It carries the carrier's eyes, ears, voice, and lungs. It helps the ship see farther, communicate more clearly, breathe more safely, and coordinate the complex machinery of flight operations. From the outside, it may look like a block of steel interrupting the runway. In reality, many of the carrier's invisible systems depend on it being there. Aircraft carriers have changed enormously since the first flat-deck ships began launching aircraft at sea. Early carriers were simpler, slower, and far less crowded than the nuclear-powered giants and advanced warships seen today. Aircraft became faster, heavier, louder, and more demanding. Decks became angled, catapults became more powerful, arresting systems improved. Radar, communications, sensors, and digital control systems transformed how carriers operate. Yet through all of that change, one feature has remained: the island. The reason is not nostalgia. The island remains because the basic problem has not disappeared. An aircraft carrier must still be a ship, an airport, a command center, and a sensor platform at the same time. Removing the island might make the deck look cleaner, but it would not remove the need for navigation, flight control, radar height, communication systems, ventilation, direct observation, and command coordination. Those functions would still have to exist somewhere. The question is not whether the island takes up space. The real question is whether any better place can handle all those jobs as reliably. Future carriers may not keep the island in exactly the same form. Some designs may make it smaller, more angular, or more integrated into the ship's shape to reduce radar signature. Some ships may separate functions into more than one island, as seen on certain modern carriers, where one structure supports ship control and another supports flight operations. Other future designs may rely more heavily on cameras, sensors, automation, and unmanned aircraft. But even then, the need for height and organized command does not simply vanish. A completely flat carrier may become more realistic in some specialized designs, especially for smaller drone-focused ships or experimental unmanned aviation platforms. But for large carriers operating manned aircraft, helicopters, support aircraft, and complex deck cycles, the island still offers a practical advantage. It gives commanders a raised position to understand the ship, the flight deck, the sea, and the airspace around them. In an emergency, that broad awareness can matter as much as any single piece of technology. There is also a deeper reason the island continues to make sense. Carrier operations are built on redundancy. A warship cannot depend on one sensor, one screen, one camera angle, or one method of communication. Systems can fail. Weather can block visibility. Smoke, heat, sea spray, damage, or electronic interference can complicate operations. The island adds another layer: human observation from above, connected to communication systems, navigation spaces, and flight control. It does not replace modern technology. It gives that technology a physical center. So the island will probably stay because it solves a problem that remains stubbornly real. The ocean still moves. Aircraft still need precise timing. Crews still need visibility. Sensors still benefit from height. Commanders still need a place where information can become decisions quickly. As long as carriers launch and recover aircraft at sea, the island will likely continue to evolve, rather than disappear. From a distance, it may look like a strange interruption on an otherwise open flight deck. But the closer you look, the more it becomes clear that the island is not the carrier's weakness. It is one of the reasons the carrier can function at all. It is the ship's tower, its lookout, its voice, its air traffic control point, and part of its nervous system. That is why, even in an age of advanced sensors and automation, the island is still there. Because the hardest part of carrier aviation is not only flying the aircraft, it is controlling the entire moving world beneath them.